By what?
The most
Numbers that are
the
here.
most numbers that are in the factor.
Greatest common factor.
No,
So
it's
it's
greatest
add all the
common
factors.
factor in between two numbers.
One at a time. What?
Greatest common factor, like it's the greatest number in between two numbers or more.
I can live with that. Okay. So we're going to find the biggest factor between numbers in a sentence. That's kind of what Nathan said. Two or more numbers. Why would I want to do this? Where would this be beneficial? Any idea? Well, the greatest common factor, oh, by the way, a lot of times you'll see this just called the GCF. So if you see GCF, it means the same thing. But basically, this is really important when you're going to add or subtract fractions. This is when you would use this a lot. For a common denominator. I'm sure you've talked about common denominators before, but this is where you would use it a lot. Or for factoring. When you get into algebra. Now we'll do a little bit of this, I think even at the end of this section, we'll do some of this. But factoring is, again, when I'm going to take out some kind of factor from either a quantity or a number or something to that effect. Okay. So, what we're going to talk about today is ways to find this. So, how do I do this? Well, there's two different ways. Number one, I can list all the factors. But I have to list all the factors for both numbers. So is this an easy process? Maybe, maybe not, depending on what the numbers are, right? If the numbers would be really, really big numbers, then to get into figuring out all the factors, it'd be kind of hard to do. Because your list might take you forever. So like we did yesterday, if we had, again, like 72, then you would have to just start going through and trying to figure out all those factors again. Okay? And we would just list them all. All right? And again, if I'm doing it this way, how do I know when I'm done?
So they're really close to each other.
So they're really close to each other, or they cross each other, or it's the same number. Right? That's how I would know. But again, now remember, so if we did 72 and we did, 100, we have to list both of them and all of the factors for both. And then we're going to try to find the biggest one that we can possibly find in each or in both of our lists. Okay? So again, some of you might not like that way. That's fine. You can do it that way. So let's continue with this way and see which one you guys think is easier. So what's my next one after 2 and 36? 3 times 4?
4 and 12.
Does 4 work?
Yeah.
4 times
18.
18. Okay. 5? 6?
Yes.
Yep, because again, look, my divisibility rules of 2 and 3, then 6 has to. 6 times what? 12. 7? 8? 8, 9, and then 9, we would have flipped over to the other side so we know we're done. How about 100?
250.
2 and 50? 3?
3 and
4?
25.
4 quarters, right? 5?
20.
6? 6 doesn't work because 3 didn't work, right? 7?
No.
8? 9? 10?
Yeah.
Okay, so what is my greatest common factor between those two numbers? What is the biggest number that's in both of my lists?
4.
4 is all?
Yeah.
Kind of disappointing, right?
Yeah.
But 4 would be my greatest common factor. So if they asked us, what's the biggest number? So essentially they're saying, what's the biggest number that I can divide out of both of those numbers? That's the same number. That's the greatest common factor. Does that make sense? Okay. So, was that easy? Yeah, it wasn't too bad, right? We got kind of stumbled around a couple of them. But again, if I wouldn't know necessarily some of them, I can always use my calculator and just divide them out, right? So that's one way you can do that every single way. So my GCF in that case would have been 4. So the second way that I could do this is by using the prime factorization. So if you liked the process of using the prime factorization yesterday, maybe you're going to like this one better. I don't know. So again, let's just use the two numbers, and obviously we know what the answers are, so it makes it a lot easier anyway. But if I'm going to do the prime factorization for 72, what would I get? Or what's my prime? How would I start? We're going to pick one of the factors, right? Or groups of factors. So which one do you want to pick?
4 and 18.
4 and 18. Perfect. Either one of those prime? No. So we break 4 into what? 2 and 2. Okay. And again, I'm going to circle them just so I know I'm done. What about 18? 2 times 9. Or we could have done 6 and 3. 9? 3 and 3. Okay. Now, still write it out like we did today. Or for today. So my prime factorization would be what? 2 cubed times 3 squared. Everybody agree? Now let's do 100.
425.
425. 4 gets broken into 2 and 2. 25? 5 and 5. Okay? So basically this is 2 squared times 5 squared. Okay? So if you do it this way, I don't know which way you thought was easier, to do the prime factorization or to do this. To me, the prime factorization is probably a little faster because you just get going right away. This, you might have to actually stop and think a little bit, and some of you don't like to think just even a little bit. So you're going to avoid this way because you have to think a lot. Especially if I don't have a calculator, and let's say the number's 1,000. Because there would be a lot of factors in 1,000, right? I could still go about and doing prime factorization probably a lot faster with 1,000 than I could trying to figure out all my factors. Okay, so when you get to this part right here, this is where it kind of gets confusing to me though. So I think this is faster until we get to this part. So now you're saying, well, what is the amount that is what is the numbers that are in both of them? So in this case right here, maybe if this confuses you by looking at those two things right there and asking yourself, what's the most that I can take out of both of those? Maybe you list them all. And I know we didn't do this last assignment, but it's basically what we did. We just used exponents to do it, right? So maybe you list them all out, and now you're saying, what can I take from both of them? So what numbers can I take from both sets? 2 2s, right? So in a sense, I might start circling them. There's one of my 2s. Here's another 2. Now, here's my next 2, but I ran out, right? And there's no 3s and there's no 5s in either one, so I'm done. So then I'm going to take those two 2s and just multiply them together. So my greatest common factor is 4. Still the same thing. So again, it's totally up to you which way you think it's easiest. But that's what you would do for both cases. Yes, sir.
How would you do it? So just like times both of them?
Right, so then I'm going to come back and I'm going to find all the factors that I circled that were in both of them, and I'm going to multiply them all together. Nope, just in one or the other. In one or the other. Okay, so good question. So then I just multiply common factors together. But as for more clarification, from one number. So that was a good question. Don't multiply them across between the two. It's either this one I'm looking at or this one I'm looking at, after I figure out what's in common. So that's where the confusion gets sometimes. At least when I do this, even though it would take me probably a little longer in most cases, I see what my exact answer is. This one you got to kind of do your calculation. So otherwise, you can come back here, and if you didn't want to take the time to write them out in expanded form, you would just look and say, well, 2 cubed and 2 squared, well, I can take 2 out of both of those, so I'd have 2 squared. But again, sometimes that confuses some people. Okay? So, let's try this out. Let's do, so you get to decide which way you want to do it. I don't care which way you do it. It's totally up to you. The 2 numbers I want you to do are 108 and 144. So realistically, maybe you do both ways. Maybe you find it easier to do this way sometimes by just listing all the factors. I might do that if, there's numbers that I really knew about. Then I might not waste my time doing the prime factorization. But it's totally up to you what you want to do. What you got?
No,
You did what?
I didn't do
What one thing did you do?
the 2s, but add the 3s.
So, notice how I did mine this time. So instead of listing them all, I just went through, and every time that I found one in both cases, I crossed them out and I listed them. Just another way of doing it. So you got to figure out what the best way for you to do, getting the common things that are from both together. All right? Anybody not get 36 besides Mr. Galvin? Mr. Colbeck, what did we do wrong?
A lot of things.
Why? You got 12. Okay. What was your end prime? Did you do prime factorizations or did you do your lists?
I missed them. I tried to do that one.
You tried doing the prime factorizations. All right. So, better try another one then. And it's easy. Thank you. All right. How about this one? What happens? What happens if I have 3 numbers? I'm going to do the exact same thing, right? So this time I either got to list them or do my prime factorization for all of them. Okay. Try it out. See what you get.
Exactly.
It's silly.
I didn't even do any work. Did
You
you?
didn't do any
Oh,
work.
no, it's 2 numbers.
Well, Well, actually, wait 1 second.
No, you're not wrong. then.
Watch it, watch her have like.
No, I'm right. I'm right.
You are?
Yep, that's what I got. Nice one, Jacob.
I didn't even break it.
Alright, so, again, I'm doing it in a whole different way, so now I'm gonna say 2 squared, there's 2 squareds in that one, 2 squareds in that one, so 2 squareds gotta be a part of it. So I'm done with my 2's. And then the 3, 3, and 1, 3, so 1, 3 here. So 2 squared is 4 times 3 is 12. So, I believe what you guys were saying is, I don't even have to really think about this one, because why?
12.
Yeah, so if I would have stopped and actually thought a little bit, which it sounded like some of you actually did, so kudos. I look at the problem and I say, well, 12 is the biggest number here. Does 12 go into this? Yeah. Does 12 go into that? Yeah. So it doesn't matter what else is factors. 12 is the biggest that can come out of this one. And if it works for both of them, that has to be my answer. That makes sense? So yeah, great job of slowing down and just looking at the problem. How do we do this then? You got the answer? Okay, so, what time do we leave today? We better stop. We'll finish tomorrow.